This is Intex GREEN X700 UPS with throw hole long PCB, and I have implemented a small mode on the board to prevent automatic shutdown when there are smaller loads connected to the output of the UPS, like LED bulb like this or a mobile charger. So I have already implemented it. Now I am going to demonstrate. I am just turning on the UPS. The mains is on. This is main switch. Okay, this is main switch, and it is already on, and I am now switching on the UPS. Okay, the LED bulb has already glown. Now what I will do, the main thing to demonstrate is, now I will, there is only this LED bulb connected to the output. Now I will switch off the mains and see. Okay, let me just with this finger. Now UPS is giving its backup. Mains is off. Fine. So let us see how long. It will not shut down unless you shut down yourself. I have already tested it and seen its duration for more than 30 minutes. But for the sake of time, so that the video doesn't get that much lengthy, I am just I will wait only for, let us say, 4 or 5 minutes. So generally, when I did not install the mode on the board, the output of the UPS was going down. The UPS was going down when mains is not available, and there are smaller loads. If the load is let us say, even the load, if the load is 40 watt or 60 watt, the UPS was going down. That was really annoying, because nowadays there is hardly any PC like in the old age, when monitor itself was more than 100 watt. And so during those days it was consuming a lot of power. But nowadays, when LED monitors or LCD monitors are there, so it is not going down. It's still, LED bulb is still glowing. It's still glowing. It's still glowing. Otherwise, it would have shut down within a minute at the maximum. So it is now close to 4 minutes. The video will get unnecessarily lengthy, so I will now switch off with this by pressing. I have switched off the UPS now. this is the transformer which is there on the UPS board, and these are the 4 diodes. They are basically on 4148 type, and in the output of the bridge there is a Zener diode ZD2 in parallel to the output, and there is one resistance around half watt. The designation is R34X 620 ohm. It is also in parallel, and then from the out positive of this bridge, this one resistance 100 kilo ohm R1AX, and after that a capacitor C14 10 microfarad 50 volt is there. So this is point C basically, and via jumper JP57, JP29, JP46, this load sense signal goes directly to pin number 12, pin number 12 of the U10 IC, which is microcontroller 32 pin. So basically, in order to prevent auto shutdown when no mains is there and smaller loads are connected, we have to remove this link, I mean from there, and we will cut in the middle this JP57, and will solder a resistance, so this is basically the point B is directly connected to pin 12 of U10 IC. So there are two options. You can connect a DP-DT switch, SPDT, single pole double throw switch. Pole of the switch has to be connected to pin B, and one throw of the switch like NOR and NC has to be connected to C, so that if you do not need need to bypass this, then you can switch, you can put the switch so that pin B and pin C is connected, and in that case the UPS will shut down automatically with smaller load like LED bulb or battery charger, mobile charger. And if the switch is switch is slided or switched to other side, so that pin B is connected to a source of a diode 4148, which is biased with a 100 kilo ohm resistance, and one pin of the 100 kilo ohm resistor is connected to 5 volt, and the cathode of 4148 diode is connected to the ground. So in forward bias, a regular silicon PN junction diode gives 0.6 volt approximately in the forward bias. So basically our purpose is solved. Rather than putting a variable potentiometer, or it is better to to give 0.6 volt or 0.5 volt, whatever it is, via a diode, forward bias diode. So basically I have traced this schematic, and let me explain it to you a bit. This transistor switches off, turns off this relay. This is the output relay. So let me just move on to the main mode. Okay, so this is basically This is the switch I was talking about. This is a single pole double throw switch, and pole of this switch is connected to pin B, I already explained earlier, and one NO or NC, it doesn't matter. This C is what? C is solder. C is solder pad of JP57 away from buzzer. There is a buzzer on the board. I have noted it down so that you can understand it very well. And point B is solder pad of JP57 toward buzzer. But we have to cut the jumper JP57 from middle and tilt the buzzer wires, the jumper wire slightly away from each other so that shorting cannot be there. And this is the main circuit. However, in the actual board I have used 100 kilo ohm. You can use 100 kilo ohm or 200 kilo ohm, doesn't matter. So this 5 volt is there is basically one jumper. I have already explained in the previous photo. So this 200 kilo ohm diode or 100 kilo ohm diode resistor forward bias this 4148 diode, and at point D there is always 0.6 volt of DC voltage available. So this pin can be connected to, this is the basic circuit, connected to pin 10 of U10. No, this is pin 12, I think. Yeah, pin 12. Sorry, it has to be this pin 12. No? Pin 12 of U10 microcontroller. So I have said remove JP57. So I have not used a switch actually. I have just connected one resistor 100 kilo ohm in series with 4148 diode, cut JP57 and pin this pin D, which you can see here. D is now connected to pin 12 of U10 microcontroller in my mode, but you can use switch so that if you need to bypass it, you can put it other way. Fine. So this is the schematic basically. On JP27, see it clearly. At JP27 there is 5 volt already available. So I have connected a resistor to JP27 and connected to other end of the resistor, connected to diode 4148, and a cathode of the diode 4148 is connected to ground, and this is the mode. It is working excellent for me for the long board.